When analyzing proportions, we need to ask the question, what is the probability of a given number of successes from a fixed number of trials? Of course, successes need not mean win or lose, or something like that. A success could mean a red fish instead of some other color of fish. We can answer this question using the binomial distribution. And the binomial distribution equation is the probability of x equals n over x times probability p to the x power times 1 minus p times 1 minus p to the n minus x power. Here, x is the given number of successes, n is the fixed number of independent trials, and p is the underlying probability of success. For example, the butter side up and down experiment, the underlying probability of success is 0.6. The n over x symbol describes the binomial coefficient. And this is the number of ways x successes in n independent trials can happen. We can represent this in the equation n over x equals n factorial divided by x factorial times n minus x factorial. A quick review of factorial calculations. 0 factorial equals 1. 1 factorial equals 1. 2 factorial equals 2 times 1. We have 3 factorial, which is 3 times 2 times 1, which equals 6. And we have 4 factorial, 4 times 3 times 2 times 1, which equals 24. I hope you see the pattern here. The factorial is just the number times the next lowest number times the next lowest number, all the way down to 1. Modern calculators have this function, so you don't have to do this all out manually. And in R, you can use the factorial function, which you'll be able to see in the R tutorial that goes along with these videos. In a binomial test, we are comparing against an expected outcome. That outcome is the expected number of successes in a fixed number of trials. We represent that as mu equals n times p. And so that's the number of trials times the underlying probability. We can also estimate the proportion of successes in the sample as p hat, which equals x divided by n. There, of course, is variability in proportions, and we can represent that variability a lot like we can represent variability in means. For example, the variance, or sigma squared, of a proportion equals p times 1 minus p. The standard deviation, of course, is just the square root of the variance. The standard error is SE sub p hat equals the square root of p times 1 minus p divided by n.